Hi, welcome back. So in this video, we are going to find the area between some curves, this time using integration with respect to y. So let's show you an example. Basically this time, instead of doing dx, we're going to do dy, and it's going to kind of flip everything horizontal. You'll see why we need to do it in a minute. So for this example, let's say we want to find the area between the curves let's do y equals x minus 2, and then let's do y squared equals x plus 4. So just looking at that y squared equals x plus 4, this isn't in our usual y equals form, so it probably doesn't look the same as things we're normally used to seeing, but that's okay. Part of what we're doing now is finding anything we want. It doesn't have to be specifically really simple in the way we've done it before. So you'll see what this looks like in a moment. But just warning you that when you see that y squared, you should sort of be thinking okay, that's a little different. That's different from what I'm used to seeing. So we're going to graph these again. I'm going to graph them by hand just to show you how to do that. So first I see that the linear function is y equals x minus 2. So that is a vertical intercept of -2, and then it just has a slope of 1. So I know that the slope is going to go 1, and I can draw that line going out from that vertical intercept. So this is y equals x minus 2. Okay. So now I just need to deal with that y squared equals x plus 4. And the way I'm going to do it is actually to solve for x. So I have x equals y squared minus 4. And now I can input y values and get outputs of x values. So I can get, make a little table here. Normally I'd plug in x values and get y values, but I'm going to go the other way around this time. Again, you can always use a graphing utility or something to help you do this. I just really think it's a good skill to be able to graph them on your own if you need to. You never know when that might be useful in your other classes when you're dealing with math stuff. So we're going to plug in some y values. I'm going to do 0, 1, 2, and 3, and we'll plug in -1 as well just to see what happens there. So when I plug in 0 for x, I'm getting 0 squared minus 4, which is -4. So that tells me when x is -4, y is 0. So I'm starting with that -4x and going to the 0 on the y. Okay, let's plug in 1 now. 1 squared minus 4. That's 1 minus 4, which is -3. So that's telling me at -3 on the x, I'm at +1 on the y. -3, 1. Okay, let's keep doing it. I'm just trying to get enough points so I can see what the shape looks like. So now I have 2 squared minus 4. That's 4 minus 4, which is just 0. So that one is 0. So at 0 for x, we have 2 for y. Okay, I'm realizing we might need to plug in a couple more points just looking at this, and that's okay. Sorry for that. Okay, let's do this next one, 3 squared minus 4. That's 9 minus 4, which is just 5. So at 5 on the x, I have 3 on the y. And then let's do -1. Maybe actually this will be enough. I just kind of was thinking a little too hard about it for a second. So now we have -1 squared minus 4. That's 1 minus 4, which is -3. So this is telling me at -3 on the x, I also have -1 on the y. So what's happening here is because that y value is squared, whatever the y value is, it kind of is symmetric in this way. So I'm going to just graph those other points. You could plug those in if you wanted to. This is sort of like a parabola turned on its side. So instead of x squared, we have y squared. And it's going to look, ooh, that's not good. Something like this. There we go. So this is my y squared, my x equals y squared minus 4. So again, you could open up Desmos or use a graphing calculator to graph this. I just like doing it by hand, and again, this will save you a lot of time if you did it a different way. It's just good to practice, I don't know. Okay, so we're trying to find the area between the curves. I now can see where everything intersects. So I have this point at 0, -2 where they intersect, and at 5, 3. So we're going to be looking at this area in between those points, sort of. But remember, the main thing we need to do is find like a above function and a below function. So normally what we would do is we'd have this vertical rectangle here. And we would find the top function and the bottom function. But it's kind of weird what's happening. So as we take this bar and sort of go through the function, the top and the bottom function change. So as we go to the second part, now the top function is the y squared minus 4, and the bottom is this line. So it's sort of weird, like what's happening. It's like it's changing which one is the top and which one is the bottom in the middle of our shape. And specifically, even if we look back at this first section, so the top function and the bottom function are both the y squared minus 4, the x equals y squared minus 4. So that's sort of weird. Like I want one function to be on the above and one function to be below. So what we're going to do here is kind of shake this up. So instead of doing dx with the vertical bars, I'm going to put in a horizontal bar. So this is my horizontal rectangle that represents all of the rectangles we're going to add up. So here now, I have a pretty clear above function if we look from like the right-hand side being above, and I have a below function on the left-hand side. So you can kind of think of like turning your head to the side, and you can see that rectangle has a height of y equals x minus 2, and minus the bottom function, the x equals y squared minus 4. Okay, I don't think that was the best way for me to say that. So let's draw this rectangle again and talk about what's going on here. So on this rectangle, I have my height and my width, and we're kind of turning our heads over. So the width is now this vertical part. And so the width is actually a change in y. So we're going up a little bit on the y there. And then the height is going to be the functions subtracted, the difference in the functions. So our above function, if we go back up and look, the above function was our y equals x minus 2. And then the below function was the x equals y squared minus 4. And so the thing I want to point out here that makes this different is now we are integrating with respect to y. So this is sort of different. Instead of having a dx, we have a dy. And so we're going to need to have everything in terms of y. So whatever we plug in to our integral is going to have y's in it. So what I need to do is solve these top and bottom functions in terms of y. So we need to get these equations in terms of y. And that's so it will look like x equals something. So in the other examples we've done, it's been like y equals blah and y equals blah, and we just like integrated without thinking too much about it. But now that we have these sort of implicitly defined things going on, where it's like x equals y squared, it's not clearly y equals, we're going to need to do a little bit of maneuvering. So we actually already have x equals on this below function, and so for the above function, I'm just going to solve for x. So I have x equals y plus 2 by moving that 2 to the other side. Now I can think about the height of my rectangle. So now if we look at the height, I have the above function y plus 2, and I'm going to subtract off the below function y squared minus 4. And so now we have the height and the width of our rectangles, and we can integrate. Okay, so the main thing we're going to set up now is we're going to do an integral, and we're going to figure out these bounds in a second. But we're going to do the height, y plus 2 minus y squared plus 4 dy. So we're integrating with respect to y. Let's go back up to our picture. So we have our above function minus our below function for the rectangles. And now we just need to figure out where those rectangles go from. So the first rectangle will start down here at y equals -2. So we can see it on the y equals -2. And we're going to put in these rectangles all the way until we get up to y equals 3. So that will be our last one. So I'm seeing that our rectangles go from -2 to 3. And those are going to become our bounds. We're going to use the y values as our bounds. So now instead of x values here, I have y equals -2 and y equals 3. And I have an integral I can solve. So it took a little bit of work. We had to maneuver things. We had to figure out which function was on the top and the bottom. There was weird stuff happening. And this is kind of, I don't want to say it's as complicated as it gets, but this is the main way that it gets complicated sometimes. It's just by having to change the variable we're integrating with and look at dy instead of dx. So at this point, we just have some fraction maneuvering, some simplifying, some figuring out how to solve the integral. So if you want, I think you're probably capable of doing this integral on your own. So you could do the integral and then check to see if you get the correct answer, or you can follow along with me and I'm going to go through it. Just know it's going to take a few minutes for us to sort of finish this problem. It just has quite a few steps to integrate and plug in the bounds and such. Okay, so let's go ahead and solve this integral. So I'm going to try to simplify it up a little bit just to combine terms and stuff. So I have y plus 2, and then I have a minus y squared, and then a minus 4 if I'm distributing that negative or the subtraction. Oh shoot. I just saw that I copied this down wrong. So if you're looking back, this should be a y squared minus 4, and then this will become a plus. So I just wrote it down wrong from what we had before. Looking at here, it's y squared minus 4. So it should be y squared minus 4. Okay, now I can combine the 2 and the 4. So I have the integral of y minus y squared, and then I have plus 6. So I put the 2 and the 4 together. Okay, we can actually integrate this just sort of straight away. This is multiple power rules. So I have 1/2 y squared, that comes from the y. Then I have minus 1/3 y cubed, that comes from the y squared. And then I'll have plus 6y from the 6. And this is evaluated from -2 to 3. Okay, so this is just the part that takes a while. We have to plug in all of these fractions. If you're really fraction fluent, it won't be too bad. We'll get through it. It's not all that too bad. It just takes a little bit of time. So I'm going to plug in 3 first. So I have 3 squared minus 1/3 3 cubed plus 6 times 3. And then I subtract off what happens when I plug in -2. So I have 1/2 times -2 squared minus 1/3 times -2 cubed plus 6 times -2. Okay, let's keep going. We just got to simplify. So 3 squared is 9. That gives me 9/2. One of these 3's in the second part is going to cancel, so I'm just getting 9, or minus 9 rather. And then plus 18. So that's my first part. Then for the second part, I have 2 squared is 4. Sorry, well, -2 squared is 4. Divided by 2 is 2. Then I have minus 1/3 times -8. That's -2 cubed. And then I'll subtract off 12. Oops. Okay, we're almost there. We really just got to combine all these fractions together. So I have 9/2 plus 9 here on the first part. And then I'm going to subtract off. So we have 2 plus 8/3 minus 12. So I combined those two negatives. Bear with me, we're almost there, guys. Okay, then we have this 9/2 plus 9. And on the second part, I'm going to combine the 2 and the -12. So that's -10 but then I'm subtracting it, so it's a plus 10, and I'll distribute that negative to the 8/3. And so here I have 9/2 plus 19 minus 8/3, and we just need to get some common denominators. So I'm going to use 6 as my common denominator. So 9/2 is 27/6, multiplied everything by 3. 19 times 6 is 114. And then 8 times 6 is 16. Oh, sorry, that's not at all what I meant. We're trying to get a common denominator of 6 here, so I'm multiplying by 2. That's 16. And then I just need to combine these things together. I did this with a calculator ahead of time to combine all these fractions, so I know that it's 125 over 6. Okay, and that is my area between the curves that we were given. Oof, okay, so that is that example. It just took a long time to solve the integral and a little bit of work to set it up, but we ultimately found the area between the curves, and we got 125 over 6. All right, that's just a little sample of the way that this can get more complicated. I'm going to do one more example video where I show another example, and this is just the last sort of thing we can encounter. So I'll show you that in the next video, but that's it for this one. Thanks so much for watching, and I will talk to you in the next one.